Hello, welcome back. We are now jumping into our second part of multiplication. In the last session we looked at times 2 as one of those first foundational facts. And now we're jumping into our times 10. We remember that the way that we're looking at these is that the foundational facts are times 2 and 10, 5, 1, and 0. So today and then our next session we'll look at those next 3, 5, 1, and 0. So in multiplying by 10 we're really looking at the roots of our base 10 number system. So the beauty of times 10 is often that kids have a lot of practice skip counting and counting by their tens. Looking at models of 10 sometimes doesn't take quite as long as some of the other models, but for some of our kids, they may know the counting, the 10, 20, 30, 40, but they may not actually understand what that represents, what the actual objects might look like for that. So we're going to jump right in here, and in the same process that we did with our times 2 facts, we'll look at a little bit of what's behind the scenes with times 10 and then build our way up through building automaticity through some games, and then at the end connect back towards how do we build students' understanding of division. So let's take a look at where this takes us, and thanks again for joining us. As we mentioned, why do we go to tens after twos? And usually the real question is, why is 2 first? A lot of times we think of times 10 and times 0 as the simpler facts for kids, and there are certainly some things that back that up in terms of kids' ability to recall. The nice thing about going into tens after twos is in twos we're really focusing on doubling and in pairs, but then in tens it's not so much the doubling in pairs, but it's that comfort level of the numbers that we've been skip counting for years, 10, 20, 30. So it's probably a blend of what's comfortable for kids and what makes sense, because once we know our 2s and our 10s, we can find a lot of our other facts at that point. So what are the big ideas here in multiplying by 10? We've mentioned a couple times already. Skip counting is a big part of understanding our 10s, but really understanding that 6 times 10 means 6 groups of 10 objects, right? So actually picturing what does that, if we're looking at base 10 blocks, for example, where is that rod, and what can I see that that's 10 individual units that come together to make a 10, and then that helps me be able to multiply quickly. Obviously, one of the big ideas, and this will probably come up every single time, is that our number system is a series of patterns. And so when we start talking about factoring and factors, those are so much easier to find when we understand the patterns that our number system follows. That is opposed to the idea that, well, when you multiply by 10, just add a 0 to the end. That we know that's not mathematically what you're really doing. It's maybe a shortcut, but it also shortcuts kids' understanding, especially when we introduce that idea too early. So if we just add the idea to kids that, well, 5 times 10, just put down the 5 and add a 0 to the end, although they get the right answer on the paper, the idea of the value isn't there. So we want to make sure we're building that conceptual understanding. And again, the idea of the commutative property, that whether it's 5 groups of 10 or 10 groups of 5, those aren't the same thing, but they do have the same value. So in terms of being able to find the answer, I can reverse the order of the numbers, and I can come up with the same value, but again, not the same thing. So our story that goes along with this one is the grouchy ladybug. And so this one comes in handy in terms of the dots on the ladybug's back. We certainly have seen that used for years in kindergarten classrooms for not just tens, but just putting in different numbers of dots on the ladybug's back, and then we're counting those. And it has both the comfort level of a familiar character, but it also allows us to bring in the actual representation of the values here. So one of the things you might ask kids in advance would be, why might this ladybug be so grouchy? You know, what would a grouchy ladybug do? What do you do when you're grouchy? What kind of things go on? So as we listen to this reading here in just a moment, we're going to go to YouTube to watch it today and do it a little differently. We're looking at things like predicting what the next animal is, But we're also remembering what we talked about when we shared the book for multiplying by twos, that we don't want to get too much into the math, especially on the first read of a book. So this book might be one that kids have read a lot, and so they may be really comfortable with it. But we want to assume that at first we want to give kids the opportunity to just enjoy the literature part of this. So I'm going to pull it up here on YouTube, and hopefully this will show nicely for you. So let me jump over here to the Grouchy Ladybug, and we're going to, I hope this isn't too sleepy, because this guy has a very interesting way of reading the story, and it's a little tired. But so let's sit back and listen to our story.
Good evening. I'm Mr. Seven. Yay! I'd like to do a nighttime reading of The Grouchy Ladybug. Nighttime reading is a quieter version of the story. It's a time for you to relax and unwind your very, very busy day. The Grouchy Ladybug by Eric Carle. The author writes a side note to help you understand the story better. He writes, aphids are very small insects. They suck the juice from leaves, and then the leaves die. Ladybugs eat aphids. That's good for trees, shrubs, other plants that have leaves. To the ladybugs, I have dedicated this book. 3 cheers. It was night, and some fireflies danced around the moon. At 5 o'clock in the morning, the sun came up. A friendly ladybug flew in from the left. It saw a leaf with many aphids on it, and decided to have them for breakfast. But just then, a grouchy ladybug flew in from the right. It too saw the aphids and wanted them for breakfast. "Good morning," said the friendly ladybug. "Go away," shouted the grouchy ladybug. "I want those aphids." "We can share them," suggested the friendly ladybug. "No, they're mine, all mine," screamed the grouchy ladybug. "Or do you want to fight me for them?" "If you insist," answered the friendly ladybug sweetly. It looked the other bugs straight in the eye. The grouchy ladybug stepped back. It looked less sure of itself. "Oh, you're not big enough for me to fight," it said. "Then why don't you pick on somebody bigger?" "I'll do that," screeched the grouchy ladybug. "I'll show you." It puffed itself up and flew off. At 6 o'clock, it met a yellow jacket. "Hey, you," said the grouchy ladybug, "wanna fight?" "If you insist," said the yellow jacket, showing its stinger. You're not big enough," said the grouchy ladybug, and flew off. At 7 o'clock, it met a stag beetle. "Hey, you," said the grouchy ladybug, "wanna fight?" "If you insist," said the stag beetle, opening its jaws. You're not big enough," said the grouchy ladybug, and flew off. At 8 o'clock, it came across a praying mantis. "Hey, you," said the grouchy ladybug, "wanna fight?" "If you insist," said the praying mantis, reaching out with its long front legs. You're not big enough," said the grouchy ladybug, and flew off. At 9 o'clock, it almost flew into a sparrow. Hey, you, said the grouchy ladybug. Wanna fight? If you insist, said the sparrow, opening its sharp beak. You're not big enough, said the grouchy ladybug, and flew off. At 10 o'clock, it saw a lobster. Hey, you, said the grouchy ladybug. Wanna fight? If you insist, said the lobster, stretching its claws. You're not big enough, said the grouchy ladybug, and flew off. At 11 o'clock, it bumped into a skunk. Hey, you, said the grouchy ladybug. Wanna fight? You insist, said the skunk, starting to lift its tail. Oh, you're not big enough, said the grouchy ladybug, and flew off. At 12 noon, it spotted a boa constrictor. Hey, you, said the grouchy ladybug, wanna fight? If you insist, said the snake, right after lunch. You're not big enough, said the grouchy ladybug, and flew off. At 1 o'clock, it happened upon a hyena. Hey, you, said the grouchy ladybug, wanna fight? If you insist, said the hyena, laughing eerily and showing its teeth. You're not big enough, said the grouchy ladybug, and flew off. At 2 o'clock, it met a gorilla. Hey, you, said the grouchy ladybug, wanna fight? If you insist, said the gorilla, beating its chest. Oh, you're not big enough, said the grouchy ladybug, and flew off. At 3 o'clock, it ran into a rhinoceros. Hey, you, said the grouchy ladybug, wanna fight? If you insist, said the rhinoceros, lowering its horn. Oh, you're not big enough, said the grouchy ladybug, and flew off. At 4 o'clock, it encountered an elephant. Hey, you, said the grouchy ladybug, wanna fight? If you insist, said the elephant, raising its trunk and showing its big tusk. Oh, you're not big enough, said the grouchy ladybug, and flew off. At 5 o'clock, it met a whale. Hey, you, said the grouchy ladybug, wanna fight? The whale did not answer at all. You're not big enough anyway, said the grouchy ladybug, and flew off. At 5:15, the grouchy ladybug said to one of the whale's flippers, Hey, you! Wanna fight? But I got no answer, so it flew off. At 5:30, the grouchy ladybug said to the whale's fin, Hey, you! Wanna fight? But they got no answer, so it flew off. At 5:45, the grouchy ladybug said to the whale's tail, Hey, you, wanna fight? And the whale's tail gave the grouchy ladybug such a slap that it flew across the sea and across the land. At 6 o'clock, the grouchy ladybug arrived right back where it had started from. "Ah, here you are again," said the friendly ladybug. "You must be hungry. There are still some aphids left. You can have them for dinner." "Oh, thank you," said the wet, tired, and hungry ladybug. Soon, all the aphids were gone. "Thank you," said the leaf. "You are welcome," answered both ladybugs, and they went to sleep. The fireflies, who had been sleeping all day, came out to dance around the moon. The end. Good night.
Well, I hope everybody's still awake. So let's take a look at why did we choose, or why did our authors choose The Grouchy Ladybug as the story for times 10. So is a good classic story. That's certainly one good reason to use it, but there's got to be more to it than just that. So let's take a look at how this is the launching pad for what we can do with multiplying by 10. So we can think about a ladybug having 2 wings, right, and how we determine the total number of spots on that ladybug, and looking at on an actual ladybug, maybe the ladybug in the book, the ladybug here on our picture. Do we count them all? And then when we get into looking at the ladybugs on our worksheets here, or the sheets, we'll start to notice that they have 5 on each side. So do we count each one of those? 1, 2, 3, 4, 5 over here, and 1, 2, 3, 4, 5 over there, or 6, 7, 8, 9, 10. Do we have some kids who recognize 5 and 5 and they're doubling it? Maybe they're using, hopefully they're using what they know about doubles and pairs. So how kids are coming to realize the 10ness here is certainly important. So in this activity, right, students are going to get a number card. They're going to draw a number card, and that number will refer to the number of ladybugs that they would put on their leaf. So I think we have a picture here in just a minute of what that looks like, but you would know that each ladybug has 10 dots on it. So we're putting the ladybugs on the leaf, so we pick a 4, so I get 4 ladybugs, I get to put 4 ladybugs on my leaf, and we're asking the question, well, how many dots are there going to be? And then having the kids actually draw it out. What's the picture look like? What does the addition sentence look like? What does the multiplication sentence look like? So hopefully this sounds familiar to what we did with our times 2, our 2 of everything book. And then we're going to do it again. So, okay, now I pull a 7. So now I have 7 ladybugs. And what does that look like in my picture? And what would it look like as an addition sentence? What would it look like as a multiplication sentence? And then doing that one more time. So the importance of repetition here, and the importance of drawing it out. Certainly kids can be as creative, as artistic as they'd like with it. We don't want to take the inordinate amount of time if that's an issue, but we certainly want to allow kids to explore and to be artistic if they so choose. Eventually, we're collecting from all across the room, well, what did you notice about if you have 1 ladybug, 2 ladybugs, 3, all the way up to 10, and how do we represent that? How can we put that into a table or into a chart? What would make sense? And just gathering how students start to see it. Are they starting to recognize the patterns? And then can they begin to predict? Obviously, if you're doing this as a whole group, this is probably better done as a small group, but as a whole group, you're going to have some kids who know it already, and then you're going to have some kids who are struggling. So that creates its own challenge, right? So as you're gathering students' observations, you're also making mental notes about who's solving it and how are they solving it. So here's our ladybug template and our number cards. Again, if you choose this book as something that will be useful for you and will provide you with that book, you would have access online to be able to download all these, print them off, turn them into folder activities or something similar to that. So We can now then extend this, right, into a little bit more formal way of drawing it out. So we've used our Ladybug template and our number cards. Maybe we created something of a chart on our own, but now we want to extend that and make it a little bit more individual or pair-based. So here's where we're making the connection directly to the multiplication sentence. So when I pulled, now I'm going to try again with pulling the number cards. I pull a 3, so I'm going to draw my 3 ladybugs on there. So I have 3 ladybugs times 10 spots on each gives me 30. And we anticipate that some kids are going to need to count those 30, right? And some are going to count them individually, and some are going to say 10, 20, 30. And you might have some kids that just say, well, I know that 10 times 3 is 30, or 3 groups of 10 is 30. And actually, it probably should be 3 times 10, right? 3 ladybugs times 10 spots. And then extending that into the writing piece here, right? So if each ladybug has 10 spots, how can you tell? How can you generalize that out? So again, not to make these sound like they are back to back to back. These could certainly be done over a series of time, working with our kids. Continuing utilizing the story as a connection point for the kids and being able to come back to that. Some similar questions, right? So ladybugs in Kim's yard also happen to have 10 spots. She catches 4 on Tuesday, 5 on Wednesday, 6 on Thursday. How many total spots did she catch on each day? And explain how you know. So we're looking at kids' progress, right? So how many total spots did she have each day? And then for other kids, it might be how many total spots did she have over the 3 days? These could certainly be partner activities. And again, this is a great place for kids to write their own number sentences about ladybugs and the spots on their back. We're starting, again, as time goes on, we want kids to start to make their own conjectures or their own recognitions about what they notice about how the numbers work. And hopefully they start to come up with things like, well, it's like counting by tens. And it's not something necessarily that you or I or somebody tells them that it is, but that they come to those realizations on their own. In looking for patterns, it's good to go with some concrete things, and utilizing the ladybugs and the spots is one way to do that. But using base 10 blocks. The paper versions are certainly fine. Probably better to have the actual base 10 blocks, because then we're looking at rows and units in terms of ones that make up tens and those pieces. If you don't have the actual physical blocks, the paper ones certainly will work. There are other tools, or you can also use your Unifix cubes, and there's certainly plenty of those floating around. If you need access to those, you can always let somebody like me know, and we can try to hook you up with those as well. So in looking for patterns, similar to when we looked for patterns with 2s, and remember when we were looking at patterns with 2s, we were noticing things like even, they always seem to be even, they counted by 2s, those kind of things. So this is student exploration and student discovery of patterning with our with our 10s. So they're going to use their rods to find the products for all the 10 facts, and so we have a similar sheet to what we did with our times 2. So let's just write them down: 10 times 1, 10 times 2, and hopefully they're laying the rods down and they're really making that connection between the physical object and the abstract number sentence here. And then once they've completed that, let's see what patterns they recognize, because oftentimes when you ask kids to tell us about the patterns, they see different things than you or I might. So some are going to see what we see, but others are going to come up with some interesting things that may or may not be really mathematically valid, but are also always good ways to tell how they're thinking. For our variety of learners, right, some are going to need more experience. So an additional way to use the ladybugs, these are a printout of the same ladybugs, just a little smaller. We can lay these on top of a hundreds chart. As they lay them on, they can see where do those fall in the numbers chart. So if my first ladybug is going to land over here and he has 10, right, so I have a ladybug here, and then I get another ladybug, and well, she goes here, and then let's see, this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 more dots, and we start to realize, well, there's something of a predictable pattern here. So what would be the next one, and where would the next one be, and maybe where is the 10th one, and how do I get to that 100? Oh, well, this is the first row, right, and this would be the second one, and the third one, all the way up to our 10th one. So again, a variety of patterns that kids might realize in terms of how how tens count and how they grow. And we want kids to be able to tell us what they see in these patterns. So this may be supporting certain kids, and it may also be challenging some of our higher kids to really think about how do numbers grow. It's always good to make connections to money and across concepts. So if we're thinking about multiplying by tens, we can certainly be thinking about how dimes make up dollars, and how, if I know the number of dimes, that tells me something about the number of cents. That maybe dimes and dollars, for some kids that's a very comfortable piece, and for other kids they may not have had a lot of experience with coins, so maybe a good way to bring in some of the other areas of math. So how we extend that, right, is not just looking at the dimes, but then going into, okay, what other story problems, story starters could we create? So some things like, okay, so if we have 4 rows and there's 10 chairs in each row, how many chairs is that going to be? So 4 groups of 10 can look like chairs. It can look like dots on a ladybug's back. It can look like dimes that go into dollars. It can look like packs of pencils, sets of crayons. So encouraging kids to find things that come in groups of 10. There are certainly lots of them out there, and being able to use those things to then make more and more mental connections to what 10 times 4 looks like and what 10 times 4 is. Once we've worked through, we've had lots of experience, kids have had lots of experience with recognizing the patterns, seeing the patterns. They may not be fluent with them yet, and therefore it's time to start building some automaticity. So once the concept is clear for kids, then we're moving into the games, just like we did with our times 2. So here's a few of those games. We encourage you to share your games on Edmodo. And please do, because we'd love to ramp this up and make it even more helpful for folks in the future. So in top tens, kids are working in pairs. Each kid's going to get a number cube or a die that has a 1 to 6 on it. They're going to roll that die and record down what they got. So if I roll a 3, then I'm going to write down on that first box that I got a 3. So this is 10 times 3, and that's going to give me 30, right? And so I've got that, and then my partner is going to roll, and let's say they got they rolled a 2, right? So my partner rolls, and they got a 2, so they're going to write 10 times 2 is 20, right? And then I'm going to roll again, and I get whatever I've got. I'm going to write that in here. It's not going to be a 0, but I'm going to write it there, and then my partner's going to go, then I'm going to go again. And once we're all done, we're going to add up our 3 values. So it gives us a little addition practice, and then that becomes my sum. So that could be round 1, we could do round 2, round 3. Just like we did with the times 2, this could be the higher one moves on from this pair into the next, and the lower one falls back. Lots of ways to make it more interactive and more fun. Again, this is one of those things that kids can totally do on their own once they're used to it. If you want to use a bigger number cube, there are certainly number cubes that go up to 12, 16. You can get all kinds of values in there, so you're practicing larger multiples, larger multiplication by 10. So just a small way to differentiate it a little bit for our kids. A second game is Keep It, Toss It. So this is kind of similar to the last one, except now kids have to make a real something of an informed decision, but also just bringing in a little bit of probability here. So you could use a spinner for this one, and you're going to multiply that result by 10. You could also use number cubes or dice. And again, you're going to roll it and multiply by 10. You have to decide if you're going to keep your roll or you're going to toss it. So if I had a good roll, so if I got a 7, right, so I might keep it. So I'm going to keep my 7, and then I'm going to go through all these, right, and I'm going to add it up and decide once I have all 5 of my values, right, so I got a 7, a 5, I'm going to toss the 1 I rolled, I'm going to toss the 2 again. I'm doing this, I should be doing this one by one, right, and actually rolling it, but so you would get the idea. I would roll, I like it, I don't like it, I don't like it, and then I get a 4, I don't like it, I get a 1, I don't like it, I get a 6, I don't like it. Well, now I'm stuck, right? Now I've got to use my next 3 rolls, and I get a 1, I get a 3, and I get a 7, right? So now I've got all my rolls because I only get 10 rolls. So once I've used up my 10, I'm done. So my 5 products are recorded, and I'm going to add them up for their sum. So I have 7 and 3 makes 10. 7 and 5 makes 12, and 1 is 13, so that's 23, right? So I got 23, my partner got something else, and I can get my largest value, right? Now, I've seen this done two ways. You can add them all up and then multiply. Depending on the skill level of the student, you may want to go ahead and do the multiplication. In fact, the rules actually encourage you to do spin the spinner and multiply it by 10 and go ahead and put that in first. So however you want to give the directions to the kids, if you want to make it more challenging, do the way we just did first there. If you want to make it easier, then let them fill in. We go ahead and multiply them as they go through. That probably gets them a lot more practice, for sure. So whatever makes more sense for you, you can see how this game plays out. And again, this could be the winner goes on to the next level, those kind of things too. So that's keep it, toss it. Math factorings is a real quick practice, right? They're going to write down their numbers in some random order. Whatever order you like is perfectly fine, or actually whatever order they like. So I'm going to put 1, 7, and 8, and 3. So I'm going to go all the way around all these, and I'm going to use up my numbers. Once I have them record on there, I'm going to quickly multiply them off. With some kids, it's nice if they exchange these. So, somebody's going to do mine, I'm going to do theirs, and we're going to see who can go around the rings fastest. You can do one ring at a time. So again, this is just making that practice a little bit more engaging and giving kids a little bit more chance to exchange with other kids and spend a little bit more time in the facts. So creating times 10 fact grids. Kind of an interesting game is to use centimeter grid paper. And so if I look on here, 3, 4, 5, 6, 7, 8, 9, 10, I hope I did that right. Now I know that those are times 10, so I could do the same rolling of dice game, right? So I roll a 4, so now I get to fill in oops, did I do 4? How about I roll a 3? So I get to make a 3 times 10 here. So I might have my kids label this. This is 3 times 10. I apologize, mine's not very neat here on the screen. And maybe as we keep rolling, your goal is to see who can fill up their card the most or the fastest. It's also a good way to create the arrays and then hang the arrays up around the room. What do they actually look like? Practicing with partners. We talked about this with times 2. It's good. It's imperative that they are tied to what kids are ready for. So practicing with partners, the times 10 fact cards, you can find them anywhere. They're certainly in this text as well. You do need to keep them based on readiness. So this would be a child who has done okay with 2s and now is ready to move on to building fluency with 10s. Working back and forth in partners. Each student having their own Ziploc baggies is a great strategy. Keeping up with student progress. So you can see, again, within this text, you get multiplication practice as well as division practice for fact checks, and a way to keep track of students and giving them, so when did they master, or how many did they master on a certain day. So if we're looking for progress just on a certain fact, this could go across that way. We'll be looking at how many you got right out of that fact check. Lots of ways to do individual practice. Again, we're de-emphasizing time. Sometimes keeping track of how long it takes a child is certainly appropriate, and you may even have kids do that. Write down how long did it take you to get through this, but not necessarily that I'm racing against other kids. So you see there's a mixed practice example here as well as just a times 10. So you have access to both of those kind of things in here. And then that brings us to division. Right, so how do we connect all that we've learned over time? And again, I know in a quick PD like this, it seems like, well, that would be 3 days or a week. And in reality, we know this is taking over probably weeks of time to really build good conceptual understanding. So modify to get to division. Now we're going to take that grouchy ladybug activity and say, instead of getting 8 ladybugs, well, now I know that I have 80 dots. Well, how many of those little ladybugs am I going to need? So let me pull them back out. Let me go back to my hundreds chart. Let me go see how I would build that. And then what does that start to look like as a number sentence? Utilizing base 10 blocks is certainly a strong suggestion here. I put the site, there are certainly plenty of virtual manipulative sites. since we're doing this online, that's kind of my go-to here. So I'm going to pull up the Glencoe site. It's there on the bottom of your screen. You can just Google Glencoe Virtual Manipulatives. The National Library of Virtual Manipulatives has the same thing. So we could look here at this and we could say, well, all right, so I see that I've got the 4 rows, and say, well, what am I trying to say here? Well, I need to know how many objects there are. How many objects there are here? Well, there are 40 objects, so it looks like, what would that look like as a number sentence? Well, 40 might be 40 divided by how many rows? Well, divided by 10, that's going to give me how many rows there are. Right? And I apologize, I think I have a division sign on this tool, right? But I could also say that, well, 40 could be divided by how many rows there are. Well, there's 4 rows. Well, then how many are in each row? So looking at those explorations and connecting back to what we've done before with base 10 blocks and what we've done with our ladybugs. So if I have a bunch of these objects, or if I have a bunch of these groups of 10, they can be individuals, right? And so I can say, well, how many are there? There's 10, 20, 30, 40, 50, 60 of them. But if they are all grouped together, and with this one it's nice because if you drag them on top of each other, they join together. And so, well, that's that same thing, right? So now it's 60 objects. It's still 60 total pieces, 60 units, I should say. But I may need to break that apart. So when I divide, what am I doing? I'm telling you how many rows there are, how many columns there are, how many are in each group. So all those things that we work on with division in kids, oops, sorry, grabbed the wrong screen. All those things we work on with division in kids can be done with our base 10 blocks. So pull this back out of the way here. So utilizing our base 10 blocks to our advantage is definitely something that helps our kids because it's bringing them back to hopefully something they're familiar with and asking them to really build the model of what they're saying. Kind of a cool game to go along with this. This one's called Write to Divide. So students are creating, in essence, excuse me, their own game. They're going to write down the values 1 to 10 up here across the top. It doesn't matter if they use the same number twice or 3 times. So they're just going to write numbers up here, 2, 4, 7, 1, 3, whatever. So they're going to fill out all 12 of these. We can put a little, we're going to put a little spinner or a little paper clip here in the middle, and we're going to spin it. We're going to divide that by 10. So if the spinner would land here on 30, I'd say, well, 30 divided by 10 is 3. Well, I get to cross out my 3 then. And so then we spin it again, and it lands on, if I had another 3 on here, then I could cross out another 3. So the first person that gets to cross out all of theirs, they're considered the winner. So kind of a fun game, relatively easy, and it gives the kids some input because if they want to put 1 all the way across there, they can, but they're going to have to land on 100 12 times, or how many times are 12 spins there. So that ends the session on times 10. I know that's a quick run through. The story takes a little bit of time there, but we want this PD to be meaningful for you. So you had a pretty good assignment with your times 2 facts, so we're not asking anything further with you other than just watching this from times 10, but I do encourage you to jot down for yourself those games that would be beneficial to you, and to share if you have resources, if you created some games or you just like some of the games that say DPI has created or some websites, throw those up on the Edmodo group. That would be great to add to this. And I will tell you that up next we move into times 5, times 1, and times 0. So we will see you soon with those, and we thank you for your time as you've been watching this. And hopefully this has added a little bit to your toolbox, and you'll be able to contribute to other people's toolboxes as well. Thanks so much.